To start to do an engraving cut, I've gone ahead and brought in a drawing, a 2D drawing of some polygons. I've set my stock up to a 9 by 9 inch piece of 3/4. I've set the 0 on the stock to this top bottom left corner. I've brought in my tool library, so I'm all ready to start making cuts. Going to the Visual Mops tab, I'm going to go to Create and 2.5 axis. I'm going to go down to the engraving, and here it's asking me, okay, I'm going to be engraving, but what line should I follow? Notice that I can select flat areas. If you've got a 3D drawing, you can actually cut two 3D areas, but I found some inconsistencies in this, and so even with a 3D drawing, I will include some 2D just polygons to select as curves. So I'm going to select those. I'm going to select these two here, hit my right mouse button, brings me back to this screen. Notice I've got two regions now selected. I can do some simple editing here by selecting these and removing, and it would unhighlight those areas that I've selected. Next, I want to go to my tools area, and I'm going to pick a large cutter here so that it's easy to see during simulation. So I'm going to pick this 1/2 inch ball mill. Notice that it tells me all my geometry pieces here from my library, including my comments. So what I have calculated in the past, MDF for this tool is 360 inches per minute. Wood would be 320. If I'm cutting this in a piece of MDF, I'd want to use 360 as my feed rate. So I want to go over here to feed rates. So ideally the cut would be 360. However, I want to do this for simulation purposes, and at 360 inches per minute the simulation goes so fast you wouldn't be able to see it in the video. So I reduced these down. I've set my cut at 100, my plunge at 25, my approach, which is just movement over, to 300. My engage is that last little movement before it starts cutting. I want to go ahead and set it my cut speed. And the retract and departure, I can go ahead and do this fairly fast, just move it out of the way. Transfer is how fast do you want me to move between this cut and before I start the next cut. The machine does have a standard rapid. We can use that, or we can set it. As you play around, you might find for some things that we want to set it up to the maximum of the machine, or at least fairly high, and you can look up in our other areas how fast that can be. The next is our clearance plane, and the clearance plane is how far up do I want to move the tool when I'm rapid traversing over to another area. I tend to use the part maximum, in other words the highest part of the part, plus a little bit of extra clearance. If this is a piece of plywood, I'm probably going to use some low-rise clamps or some screws, so 1/4 inch above it is probably safe. If I had a lot of hold-down clamps, C-clamps, or something like that, or large blocks around it, I'd want to move that even higher. So once I've defined this clearance plane, the next thing is the cut transfer method. I always use clearance plane. This means that it moves the tool up to this plane that we've defined up here, moved across to the next cut, and then plunge down in for the next cut. Skim clearance allows it to follow the contour of the piece as it's moving from one cut to the next. This wastes a lot of time and puts a lot of stress on the machine, so I always use the clearance plane. The next is cut parameters. This is how much do you want me to cut. The first thing is tolerance. How much do you want me to, how closely do you want me to go to the lines that I'm cutting to? I like to set this out to 1/10,000ths, that is 4 decimal places. The next is location of cut geometry. Where are my lines in relation to the stock? I have them at the top, so I want to pick top here. Then how deep do you want me to cut? I'm going to cut to 600,000ths just to show in simulation, take out a big block of material. And then it's going to ask me roughing depth and finishing depth. These two numbers have to equal the total depth of cut. Roughing is a way to remove a large material very quickly. And then finishing, we don't want to put as much pressure on the tool, so we want to take off less material. A safe amount of material to take off is typically the diameter of the cutter. So in this case, with a 1/2 inch cutter, I could take 500 thousandths off with no problem. Finishing cuts are usually half the cutter or less. So I could set this at 500 thousandths. And if I click outside the box, you'll notice that it automatically calculates that would give my finish depth at 100 thousandths. However, for this simulation, I want it to run longer and take more time so that you can see it. I'm actually going to set the roughing depth at 400 thousandths, and the finish depth then would become 200 thousandths, and this would give me a little bit more to play with, a little bit more material to take off during finishing. Next thing it's going to ask me is, okay, during roughing, how deep do you want each cut to be, each pass around? Again, I'm taking off with a 1/2 inch cutter here. I could go up to 500 thousandths with no problem, but I want this to run longer, so I'm going to do 200 thousandths. If I do 250 thousandths here, it's going to take 250 thousandths on the first pass, and then it's going to take 150 thousandths on the last pass, or the second pass through, because it's going to divide up the best it can this roughing depth. On finishing depth, I could leave this at 100 thousandths. Since it's 200 thousandths total finishing depth, this would give me 2 passes with this, and that looks pretty good. The next is entry and exit. This is how does the tool enter the part or enter into the line. Play around with this. I have found none works fairly well for the most part. You can try this and simulate it and see if it makes cuts in ways you don't want. So for the most part, use none, but feel free to play around with some of these settings, and especially in simulation mode. Sorting is, at what order do you want me to cut these? Now in this instance, we've only got 2 cuts that we're making, or 2 different areas we're cutting, but we may have 1,000, 2,000, especially if we're drilling holes, things like that. The order in which it cuts it is dependent on the order in which you drew them. So if I say no sort, it's going to cut the one that I drew first, then move on to the next, and so on and so forth. This can waste a lot of time, especially if you have a large number of similar cuts. So if we move to something like minimum sort distance, it will move to the next closest. My suggestion is try playing with these to see what looks to be the most logical way to cut, and try it in simulation mode. It'll save you a lot of time on the machine. Now that we've set all these parameters, we're going to go generate, and you'll see here these multiple blue lines that were generated. That is the center of the tool moving along. That is what is known as the tool path. To see how it actually looks cutting, we're going to go back to the Mops tab. We're going to go to Simulate, and with engraving, our tool path here, engraving, marked or highlighted, we're going to hit Simulate, and you see here the tool actually run around and make these cuts. Like I said, this is cuts fairly quickly. I'm going to zoom in on this, and you can see this cut, this nice trench. And if I zoom in closely, you can see here it's actually a curved bottom, indicating that this was done by a ball end mill. If I click off to the side a little bit, this orange line indicates this is my original drawing line. So notice an engraving piece puts half of the cutter on each side of the engraving line. So if I've drawn a box 2 inches by 2 inches and engrave around it, I end up with a box on the inside that is actually smaller than my drawing. So this is a big thing to keep in mind. Engraving follows the line with the center of the tool.